Okay, this is question 2 of the WJEC New AS Physics Unit 1. And this question is about particle physics. And question 2a, we are asked for state the difference between baryons, which is italics, and mesons in terms of quark makeup. Okay, it's 2 marks, so 2 things we need here. So the first thing you need to write down is a baryon. Now a baryon is made up of 3 quarks, okay? However, a meson, this is the definition we just need to learn, a meson is always a quark anti-quark pair. Okay, so if any particle is made of a quark anti-quark pair, we can define that as a meson. And that's the difference in between a baryon and a meson in terms of quark makeup. Now, when 2 protons collide, the following interaction may occur, and X is the unknown particle here. Pi 0 has no charge. Status quark makeup. Well, based on the quarks present, a proton, the quark structure of a proton is an up, down, and so 2 protons up, down. And that's something you might just need to learn, that the proton is an up, down, which means that our pi 0 has 0 charge, so it must be a quark, an anti-quark of the same type. Okay, so it's either going to be an up, anti-up, or a down, anti-down, and you just need one of those combinations. Okay. Identify particle X, explaining how you use the concentration of baryon number and one other. Well, a baryon number is very simply, if it's a baryon, it has a baryon number of 1. If it's not a baryon, it has a baryon number of 0. If it's an anti-baryon, like an antiproton, it would have a baryon number of -1. Well, here we just got matter, not antimatter. So on the left-hand side, so talk about the baryon number first of all. On the left-hand side, proton is a baryon, because it's made of 3 quarks. So it's 2 protons plus 1 equals 2. So the baryon number on the left-hand side is 2. Because baryon number must be conserved, whatever's on the right-hand side must also have a baryon number of 2. So on the right-hand side, we have proton, which is 1, plus whatever X is. Now, pi 0, we are told pi 0 is a meson. A meson is not a baryon, so the meson has a baryon number of 0. Okay? Which means that X must have a baryon number of 1. Okay? We need to use one other conservation law. Okay? The other one we're going to use is charge. So let's talk about charge. On the left-hand side, the charge is 1 plus 1 equals 2, because the proton's got 1 charge plus 1 charge. Which means on the right-hand side, it must also be 2. The proton's there is 1. We're told the pi 0 has no charge. Okay? So the charge of the pi 0 is 0, which means the X particle must have a charge of 1. Now the only particle which has a baryon number of 1 and a charge of plus 1 is a proton, and therefore we can say particle X is a proton. Okay? And we could say because it has a charge of plus 1 and a baryon number of 1. Okay? And that will get us all 3 marks. State how lepton number is conserved in the above interaction. Well, a lepton is a fundamental particle. It means it cannot be broken down into any constituent parts. Protons are not leptons because they're made of quarks. Okay? Leptons are things like electrons or neutrinos, that sort of thing. So on the left-hand side, because there are no leptons, the lepton number on the left-hand side is 0. On the right-hand side, a proton is not a lepton, has 0. We've deduced and worked out that particle X is another proton, so it's going to be 0. And we're told that pi 0 is a meson, which is not a lepton, so it also has 0. So the left-hand side, the lepton number is 0. On the right-hand side, the lepton number is also 0. Okay, so you can say the lepton number of both sides is 0. Looking at part C of the question, it tells us here a pi 0 decays in a typical time period of that many seconds into 2 photons shown below. State which force is involved. Well, because we have 2 photons produced, it's going to be the electromagnetic force. That gets us 1 mark. Give 2 reasons. Because 2 photons are produced. Okay, that's the second reason. That's the first of the 2 reasons. And the second reason is because we need to look at this time period here. Okay, this is if for it to be the strong force, it's far too long. So you can say it's too long for the strong force, which happens much quicker, and it's too short for the weak force. Okay, you could also say things like because there are no neutrinos involved, it's not going to be the weak force. You could say because there are no leptons, it's not the weak force. Many other different possibilities here, but those are the two main ones. Okay, that was question 2. We're now going to move on to question 3.